Okay, so this is the setup, the program setup for Pasco capstone for the adiabatic compression exercise. Okay, start off with we'll do the hardware setup. I have 3 sensors connected, and they're all voltage sensors. So channel A is going to the voltage is going to correspond to the pressure. Channel B is the volume, and channel C will be temperature. Okay, now we have to set up the equations. So pressure, oops, is going to equal 100 times the sensor readings from voltage from channel A. All right, that will be kilopascals. Then the volume, that we're going to have to determine. So you have to see how the volume and the voltage relate. So I have the piston, and I'm going to find what the voltage is at the bottom when the piston is at its lowest. And then I'm going to find the voltage at the highest. Okay. So I know the height when the bottom of the piston, uh, when it's at its highest point, it's at 15.6 centimeters, and when it's at its lowest point, excuse me, it's at 8.9 centimeters. Um, so I've already determined the relations, the equations here. So this is the volume in cubic centimeters. So the inner cylinder diameter was 4.437 centimeters, and there it is at its highest point. And the voltage when the cylinder or the piston was at its highest point was 4.9. I'll update that. 4.939 volts. Okay, and at its lowest point, it was 1.790. Okay, so this is just simply the slope of the change in volume over the change in voltage. And this, once I knew the slope, and I know that it's a linear relationship, I just um, plugged in a value there. Let me verify this is fine. Okay, A4, sorry, A4 is the slope that was calculated here, multiplied by 1.782, and V2 is the volume at the lowest point. Okay, so I just found the B-intercept. All right. Okay, let me update this equation. I'm just going to copy it directly to the equation on the other page. So that's 32.898. I'll just round to the thousandths place. 898. And delete the rest. And over here, I'm just going to keep also to the thousandths place. 78.988. Okay. And then I'm just going to take this quantity here and put it into this equation. Okay, and this will be centimeters cubed. I didn't like that because the voltage should be the readings from sensor, the sensor from channel B. And very sensitive. Okay, and finally the temperature we can just get from um, a card insert that's on the side of this apparatus, and that's 36.649 times the sensor reading plus 2.149. Okay, and this will be in Kelvin. All right, we are ready to start our experiment. Let me get rid of this here. Okay, and I'm going to just drag graphs. And this will be the pressure versus time. And I'm going to add 2 more graphs. The second one will be volume. Third one will be temperature. Okay, I'm gonna get rid of the last run. Now I'm ready to start, but I gotta make sure that this is set to a very high frequency. I'm gonna set it to 1000 Hertz, and the other channels will also be at 1000 Hertz. And I'm gonna record. Okay, that looks good. All right. Next thing, so you'll get this data. I'm going to delete these other graphs, and then I'm going to plot pressure versus volume. Okay, that's about right. This will probably look like something you have in your textbook. And I'm going to do a few more equations. Two. Okay. All right. And then I'll just edit the graph. This time I'll plot the logarithm of pressure versus the logarithm of volume. Okay. And then you can find the slope here. Okay. Oh, right. Let me bring this down a little bit. There you have it. Okay, that's it. That's your lab.